Hi, welcome to Marker Board Videos. Today's video is part 2 of the history of the atom, and we left off, the next person we wanted to talk about was Rutherford. And Rutherford did an experiment with gold foil and alpha particles. That's the Greek letter alpha. So in his experiment, he took very thin sheets of gold, sometimes just several atoms thick, and he shot alpha particles at them, which they knew what the alpha particles were. They were positively charged. And what they found was that most of the alpha particles went right through. However, some of them were deflected and some of them even bounced back. And so through a series of investigations, they were able to figure out, again, their best guess as to what was going on. And so what they think was happening was this. The particles that went through just went straight through, but the particles that were deflected actually hit something, not straight on, but hit it with a glancing blow and were deflected off. And some particles hit and were deflected totally. So he said there's got to be something there, and it's got to be positively charged. So the nucleus is the center, it's positively charged, and we know that because of the gold foil experiment. But please note that most of the electrons traveled straight through. So what did he figure out? He figured out, first of all, there's lots of empty space because the vast majority of alpha particles just boom, went right through. He said that the nucleus, or the center, has to be positively charged because it deflected negative particles. But also, deflected the alpha particles. It also said, he also decided that the nucleus had to be dense. It had to be massive. Now when I say massive, I don't mean large in size. It just means that it has to weigh a lot compared to some of the other things. So to sum it up, Rutherford's model says that the atom is neutral overall, that it's made up of positively charged nucleus, and we know that the protons are in the nucleus, that it is surrounded by clouds of electrons that are somehow orbiting around. We're not quite positive how yet, but we know it's orbiting around, and that there's lots and lots and lots of empty space. So that was Rutherford's contribution, and then came along a guy named Bohr. And Bohr came up with a model that we actually still use today. It's one of the simplified models of atomic theory and atomic design. But the Bohr model says that the electrons circle the nucleus in circular orbits at high speeds. A very simple way of looking at that would be like the planets and the sun. If the sun were the nucleus and all of the planets were the electrons, they circle around the sun. The orbits hold a finite number of electrons. So each orbit can't hold like as many electrons as it wants. It has a certain number, and that number is limited. And that the orbits are called energy levels or shells. And you'll hear me refer back and forth between energy levels and shells. Those words are synonymous. They mean exactly the same thing. It's where the electrons are when they're orbiting around the nucleus of an atom. So when you look at your periodic table, the rows, which of course are the ones that go horizontally, they're the ones that go this way. The rows actually tell you which energy level or energy levels you're going to use. If it has the first shell or energy level, that can hold up to 2 electrons. It's the one closest in, it's smallest, it can hold up to 2 electrons. The second shell, or the second energy level, can hold up to 8. And the third one could hold up to 18. Now, we can go beyond that, but that goes beyond the scope of this course. So we're just going to do first, second, and third shell, 2, 8, and 18. Probably a good idea to memorize those numbers. And when we get to take a real close look at the periodic table, you'll see what I mean when I say the rows tell you exactly what shells you're going to need.